Thanks, Paul. Jason, I know you're online. Are you ready to go?
Yes, let's.
All right.
I'm just thinking. I think maybe it's best if I share my screen. And
Yep.
I will, because yeah, Michael's gonna join me for this one.
Okay. Michael's joining you. Okay, cool. Okay, so you're going to run this, Jason?
Yes, sorry, I'm just changing. Give me a sec. I'm just trying to share here. I've got a bunch of screens now in the way.
Jason, could you come on video as well?
Okay. It should be better. Everyone can see me and see the screen share.
Yep, we can. You're good to go.
Okay, so yes, welcome everyone. Today will be me and Michael doing the presentation on revised settlement using TigerBeetle. So yeah, I'm gonna hand over to Michael for the first part of the presentation, and then I will take the second part. So over to you, Michael.
Thank you, Jason. Hit me.
Okay, there we go.
Okay, we're not going to bother with the agenda. We'll just keep going, I think.
Yeah. Yes, happy with that.
Okay, so I just want to talk about the background to this, about what we're trying to get done, and then I will stand back and let you marvel at the amazing things that have happened and the number of rabbits that are going to be removed from hats in the next 20 minutes. So, where we start at the moment. Today, all transfers that go through the Mojaloop system are recorded against a single position account per participant, per currency, obviously. The net debit cap, i.e. the amount of liquidity cover for each account type, participant, currency, is recorded as a separate entry. We support multilateral net and continuous gross settlements, but not bilateral net. And crucially, whenever a transfer completes in the Mojaloop system, it's assigned to a currently open settlement window. So we just throw everything into a bucket. Settlements are requested by selecting the IDs, the identity numbers, of the settlement windows that we want to include. You can close the settlement window at any time. When you do, what happens is that that window is closed at some indeterminate point, and now all the transfers are routed into the new window. And position accounts are updated by the amount of the settlement before the settlement completes. Next slide. So, it's a problem that all transfers are assigned to a single settlement window, and it's even more of a problem that they're not deterministically assigned. So you can't tell by looking at a transfer which settlement window it will occur in. And in particular, you can't ask a question like, tell me about all of the transfers that completed yesterday, at least not for purposes of settlement. You can do a report on that, but even if you say at the midnight, close the settlement window and open a new one, you don't know whether some transfers from tomorrow will have got into that settlement window before it was closed, and therefore every day's settlement window will contain a few transfers from the previous day, a lot of transfers from that day, and a few transfers from the next day. Now, the other problem is that if a single transfer within a settlement window can't settle because there's some dispute about it, that prevents settlement processing for all settlements in that day. And although settlement models can be segmented already by ledger account type, we don't yet have a standard way for the switch to assign a ledger account type to a transfer. So you remember when Min was talking this morning about wanting to settle remittance transfers in a different way from internal transfers in the system. What that equates to in our world is the ability, by considering the attributes of a transfer, to decide which ledger account it should be assigned to when it's assigned for settlement. Okay, next slide. Okay, these are nice wordy slides, aren't they? But rest assured, it's going to look much better in a minute. So, what do we want to do? We want to support multiple settlement models and batches, and we want those batches to be definable by administrators. Our objective is for administrators, operators of schemes not to have to go back and make changes to code in order to implement new settlement models. We want to make sure that all transfer can be recorded against the right settlement account, and we want the net debit cap to be recorded as a balance in the settlement account for that settlement model. So effectively, we are now wanting to compare two accounts with each other in order to decide whether there is liquidity cover for a transfer. We want to, well, okay, 4 we've already got, I think. As a transfer completes, we want to be able to assign it to the correct settlement batch based on its characteristics, and we want to request settlements by saying which settlement model we want to settle, and we want to give the characteristics of the batches. Instead of saying, I want to settle batch 376, 374, and 393, we want to say, I want to settle everything that happened between 4 o'clock and 6 o'clock yesterday. That kind of thing. We want the same method used to query the state of settlement batches and to request that they be settled. So effectively, we would like people to be able to define a set of batches, to look at the contents of those batches in real time as they're being updated, and eventually to take the same batch and say, I'm happy with that, I want to settle it now. For deferred net settlements, we want to be able to automatically update by transferring from the position account to the settled funds account at the point of settlement, because we don't want to have to go back and have a manual process managing that. Part of the point of requiring liquidity cover for transfers is that we should be always confident that there is sufficient funds, settled funds available to cover any party's obligations on any transfer, on any settlement. And for immediate gross settlements, we'd like transfers to be journaled across from the position account to the settlement account as they complete, as a normal process. Next slide. I'm not quite sure what to say here. So this shows you the things that we are going to add, and indeed in some cases, the things that we're going to take away. But I think I've kind of gone through those. So I am going to say, hit me, Jason.
Okay.
Okay, you're going to take over with this now.
That's right, yes. Thank you, Michael. Yes, awesome.
No.
Okay, so yeah, I'm just going to start here. So I'm Jason Dubar. So I'm responsible for doing, leading up the implementation work for settlement, for this new settlement. Apologies for not being able to attend in person today. Hopefully in the next convenings, I'll make sure that I'm there. Okay, so before we jump into the inner workings of settlement, I just want to outline the progress that we've made for PI20, looking at the key objectives. So can everyone see my mouse cursor? So looking at item number 1 here, the user stories are basically continuously created as the requirements are refined and gathered for this settlement, which is currently underway. The user stories are also currently being peer reviewed. So keep an eye on the project in ZenHub to specifically the settlements tag to see a lot more stories being created in the coming future. Okay, so then looking at the batch and model allocation, we have refined the manner in which settlement transfers are allocated to batches. Further refinement of that will also be done as part of the next PI. The settlement model allocation for transfers have also been refined. So there's a lot of refinement happening. Okay, so item number 3, we have gone through a process of defining the requirements for the settlement matrix. We will be refining those requirements even further in the next PI. So we've obviously started with really going into a lot more detail and scoping and gathering requirements and doing development on the new settlement. So there's a lot of refining going on and making sure that we're covering all the functionality that we need. And then item number 4 here is, at the start of the PI, it was very important for settlement to be compatible with Central Ledger as well as vNext in terms of the transfers BCs, the participants BCs, etc. And since we are combining the settlement service with vNext, it made sense to prioritize the settlement development in order to support Central Ledger and vNext. So that's a really great thing, I think, that we were able to, or busy achieving. Okay, so next slide. So batches. So as I'm just adding on to what Michael already basically said, the purpose of the batches are to group a set of settlement transfers and accounts together in order for those transfers to be settled as a group of batches or settlement matrix at a later stage. So the process here in which that occurs, the batch and model allocation for a transfer is as follows. Step number 1 here, the prepare. Once the quote has been accepted, the prepare operation will be responsible for obtaining the settlement model in Central Ledger and Transfers BC. The next step is to invoke what we call the engine, which is, in the case of Central Ledger, it will be the rules engine, and in vNext, it will be the settlement model lib. It would be invoked in order to obtain the correct settlement model. The reason for this is because Central Ledger and Accounts and Balances BC, in the case of vNext, has the visibility on which accounts are being impacted due to the settlement obligation being created. Okay, so in step 3 over here, you basically assigning the settlement model to the transfer, and then back over to Central Ledger and Transfer, where once the two-phase transfer is fulfilled, the transfer is regarded as being completed, which now qualifies the transfers to be sent to the settlement service. Okay, so now step 5, where we're invoking the settlement, a settlement transfer request is created in the settlement service. Now, this is a big distinction of where you've got the settlement transfer actually living separate to the Central Ledger database, if you will. Okay, so yeah, the settlement service will make use of the settlement model, the transfer amount, the timestamp, the currency, the payer, the payee, etc., from the original transfer fulfillment, basically. And then that transfer may either be published as an event or it can be posted via the settlements REST API. So we've got multiple entry points for that settlement transfer to enter the system. Okay, and jumping over here, once the transfer arrives in settlement, so the trigger here is as soon as the settlement transfer is received by settlement service, the process of creating the obligation is kicked off. Now, post the validation, coming on to step 7 here, the correct batch now needs to be obtained for the transfer based on the transfer criteria. The settlement batches are first and foremost allocated based on time spans. As Michael also mentioned, you will have a batch that would live in a normal operation, either it can be in a minute, seconds, or days, or hours. Okay, and then the batches are furthermore allocated according to settlement model, transfer currency, etc. So this is where we are in the process of providing allocation mechanisms that would allow for much greater flexibility when allocating batches for settlement. Okay, so basically when there is no available open batch at the time of the transfer, a new batch is created for the transfer based on allocation configurations. Another, or the last very important characteristics for a batch is being able to create settlement batches for settlement transfers arriving late. So there where the transfer was supposed to be allocated to is already closed, as an example. In this scenario, we have the batch sequence counter in order to retain the batch identifier characteristics, but without breaching contract of having transfers be allocated to batches that have been closed. So basically, we are keeping a lot of the same characteristics for the batch identifier, but then in day-to-day operations, 99% of the case, you will not face this issue. But in the event of some, let's for example say that there was late transfers for settlement, and a batch that was allocated for the transfer has been closed, there is a mechanism in place making sure that the batch, a closed batch is not impacted, and another batch will be created with an incremented sequence counter. Okay, so once we have a batch for the transfer, we now need, okay, so we've got a model, we've got a batch, and now we need to create an account for this, or create or fetch an account, payee and payer accounts for this transfer. Okay, so now that the batch is determined, the participant accounts that would exist per Mojaloop participant and per settlement batch will be created or fetched. Each of the settlement accounts still tie back to the Mojaloop participant account by storing the participant account ID. These accounts will exist in accounts and balances BC, which in turn makes use of TigerBeetle to store all accounts and ledger entries across the Mojaloop stack. So yeah, these areas are where we're now getting to make use of the TigerBeetle backend. And then finally, now that we've got our relevant accounts and accounts that are created per batch, we can now create the transfer using accounts and balances again, which in turn goes and makes use of TigerBeetle. And at this point, we have our settlement obligation that is now created, and yeah, transfer is in. Okay, so next slide. So now so now that covers our batches and the batch and model allocation for these transfers. The next step then is the settlement matrix. So the purpose of the settlement matrix is to group a bunch of settlement batches together based on certain criteria, then performing actions based on the result of each matrix. During the course of the day, we will have multiple transfers allocated to batches, and those batches will have different characteristics. And unlike today, where we've got a single open settlement window and transfers being allocated to the open window, we now can have multiple open batches depending on the characteristics of the transfer coming in, and allocating those transfers to various batches, open batches, obviously. Okay, and then very importantly, that you will still only have each transfer belonging to a single batch. You can't have a transfer belonging to more than one batch. Okay, so looking at the steps over here, we as an example here, the admin API, so the hub operator, at the time of settlement, the settlement matrix would be generated in order to get a view of what the result of settling would entail. The settlement matrix contains the balances, batches, and accounts for the batches in order for central ledger and participants BC to correctly update liquidity accounts later on. So this matrix gives you a nice snapshot or nice view of what exactly it is that you'll be settling. And then the second step over here, once you request when you request a settlement matrix, the criteria being used for the generation of the request is the from date to date, settlement model, and currency. We are in the process of expanding on that and providing, reviewing and providing more criteria and more flexibility in which you will be able to create a settlement matrix and be able to use that criteria going forward. So then it's the responsibility of settlements to go and fetch all of the settlement batches that match that criteria as part of the request in step 2. That match criteria will then be, if we go on to step number 4 here, the settlement matrix request will then be stored along with the batches for the request, and this creates a static view for the settlement matrix to ensure that at the time of settling, only batches the hub operator wants to settle are settled, avoiding any surprise batches, basically. And then finally, the caller gets given an identifier which can be used to settle later, and also to query accounts and transfers and batches in settlements. So that matrix ID gives you a nice anchor to work from to be able to fetch the rest of the data that you need later on, or the data that you need to go and query everything that you want to query prior to actually executing a settlement or closing settlement batches. Okay, so now what we have is a whole bunch of transfers that's been allocated to batches. We've created a settlement matrix. You are able to create multiple settlement matrices and choose to act on that or not act on that. It's all up to the hub operator, and the objective here is to accommodate the operations of the hub as much as possible before making the decision of actually settling. Okay, so the final bit here where we actually want to execute the settlement matrix. So basically, now that the hub operator has a clear view on what can be settled, the natural next step would be to perform settlement, which involves the closing of a settlement matrix and its respective batches and accounts, followed by settling all of the accounts in the settlement matrix. So that makes it basically final. Okay, so going through the detail over here is we've got the hub operator triggering the actual settlement. The settlement service kicks off the settling process with the matrix ID, which was obtained in the previous slide through the requesting the settlement matrix. We then fetch all those batches that form part of that earlier matrix request as it was stored. It will then be, the hub operator will then invoke a close operation on the settlement matrix batch, on the settlement matrix. And at that point, batches that are not closed for the settlement matrix is closed, which means now no new transfers will be allocated to those batches. So those batches are now final. And at that time, all of the account balances, so basically, all of the accounts associated with all of those batches are also now regarded as closed, and those balances are recorded. And those batches along with their accounts are final. Okay, and then at step number 6 here, we then generate the actual matrix. So now, based on all of the data that's been captured up until this point, the settlement will now generate the settlement matrix, which will contain the settlement batches, accounts, and all of the balances for those account and batches. So this information is what needs to be used in the external system with regards to like central ledger and participants BC. So if we look at the final step over here, the central ledger and participants BC will now update the participant account liquidity balances based on the settlement matrix or the settlement matrix events. So we are in the process of getting the most effective and most efficient way of also performing these functions. Okay, so now the hub operator or DFSP will at any time be able to drill down into the detail for each of the transfers, accounts, and batches in order to assist in reconciling any settlement discrepancies. So we are constantly thinking about how we can make it easier for hub operators to maintain the system and to troubleshoot any discrepancies. Very important. All right, so then, yeah, what's the objectives for the next PI? So basically, we are going just continuing on to what we've been doing, with the exception of focusing heavily on the implementation for vNext and Central Ledger, being able to successfully integrate the settlement into these two areas, as well as mentioned earlier, we are still in a process of refining and making things better and adding features and brainstorming, if you will, all of the possible cases that we need to cover for this settlement. Okay, and then yes, that is it. Thank you very much. So we are going to do a demo of settlements and where we're at in a couple of minutes. So we'll be doing that with Pedro and the vNext team, and where we will basically walk everyone through these events that I've just spoken about now.
Could I just add something, Jason?
Yes, go ahead, please, Michael.
Okay, I just want to tell a little story. So after the convening in Zanzibar, the last convening we had, Jason and I happened to be on the same flight back to Europe. And we were sitting in the departure lounge, and Jason said, you know, this settlement stuff sounds pretty interesting. He said, I think it might be a way of starting to implement TigerBeetle and incorporating it without having to do all of the central ledger stuff. Would you mind, he said, if I developed a bit of code? Well, after I'd bitten his arm off, we got into this. And over this PI, I think it's an absolute textbook case of how these things are supposed to work. So I want to congratulate not only Jason, but also Paul Baker and the core development team who've done work on the central ledger side of things, Pedro Barreto and the vNext team who've done work on the vNext side of things, and Paul Makin, who's been contributing on the requirement side of things. I think this is really a textbook example of how people in the community can pull together and, as you're going to see in a couple of minutes, really make a difference. So, applause for them, please.
And especially you, Mike.